Alright, so we're going to look at section 10.2, which is on solving systems. We can review, well, we could review how to do something with elimination, or we could just jump into using what's called a matrix. Does anybody want me to review? Probably wouldn't do a 3-variable problem with elimination because that'd take like 15 minutes. It'd take a while. But does anybody want me to review a 2-variable problem with elimination? No? Okay. So then we'll jump right into this would have been a review, so I'm going to skip this one. And we'll just start talking about what a matrix is. So a matrix is just a way of organizing information. If you do it on a computer, a lot of times it's called an array. Specifically, we're working with a 2-dimensional matrix. That means it has rows and it has columns. And that's what I'm going to start talking about first, what a matrix is. So first of all, the way we describe a matrix is by the number of rows and columns it has. So if you said to me, well, I need to make a matrix that has dimensions 3 by 5. If you're telling me you have a 3 by 5 matrix, I know it has 3 rows and it has 5 columns for a total of 15 spots. So 3 rows would look like this, and 5 columns would look like that. And you'd have a value in every one of those spots. We're going to be using a matrix to store numbers, but you can store anything. So a matrix could store, names of people, whatever you want to put. We're just going to use it to put simple numbers, that's all. If you have a matrix that has exactly the same number of rows as it does columns, then that's called a square matrix. So 3 by 3, that would have 3 rows, 3 columns, and that's a square matrix. It is important when you describe the dimensions that the number of rows is always first, columns is always second. It's rows by columns. Each thing that you put in a matrix is called an element. So an element is like a specific entry in the matrix. And you may want to reference a certain element. I might ask you, like, what's the element in row 3, column 4? You'd tell me the value that's in row 3, column 4. Now, what can be a little confusing about matrices or arrays if you're doing on a computer is what is the first row called? Is the first row called row 0? Or is the first row called row 1? Well, you can do it either way. Most computers call the first row or column 0. So it's 0, 1, 2, 3, and so on. It can be a little confusing if you call the first one 0. So we're not going to do it that way. We're just going to call the first row, row 1. First column, column 1. We're not going to do the 0 then. The 0 is pretty common to do it that way. So one pretty standard notation for a matrix is to use a capital letter. And if you go on your calculator, there's a whole bunch of things that it can do associated with matrices. And if you press second and then plus matrix, you're going to see that the calculator can store several matrices in it, all the way from A to J. So that's 10 different matrices. And the names that it uses for each matrix in the calculator is a capital letter.
Sorry, how did you get there again?
You can press second and then the fourth button down on the left is matrix. Now, the brackets around there, that's the notation that a calculator uses to indicate that something is a matrix. It puts brackets around it. And we use that notation as well. Generally, if you want to describe something as a matrix, you put brackets around it, so that way the person looking at it knows it's a matrix. This is a 3 by 3 matrix. It's a square matrix. And if I ask you about, say I want to know what's in row 2, column 3, this is the notation you can use in math to describe what's in row 2, column 3. So row 2, column 3 is the number 9. If you were doing it on a computer, it would look a little bit different. Might see something like that. You'd see a notation that represents the name of your matrix, and then brackets for the row, brackets for the column. So it's a little different, but it's getting at the same idea. So
how come the A in that? So did you already go over that?
Generally, when you're referring to an element in a matrix, they use the lowercase version in math when you're writing it. And when you're referring to the matrix itself and not an element, they use the uppercase version. Computers don't do it that way. So that's different. They just use the name of this all the time. That's how they do it. And we're focusing specifically on a two-dimensional matrix that has rows and columns, but you could have as many dimensions to your matrix as you want. 3D is common. Once you get beyond 2D, though, visually writing it on paper doesn't really make sense. It's kind of hard to do that. But in a computer or calculator, it's very simple to represent 2D, 3D, however many dimensions you want to have. Any questions about that? And if you're wondering, well, what would possibly be the use for like a three-dimensional matrix? Well, let's say I wanted to make a matrix in here where you're sitting. Well, that's pretty natural. You know, I could have, like some matrix, let's just call it, just call it seats. And then there would be two elements. There'd be a row and there'd be a column. So for each element in my matrix, I would go to a certain row and a certain column, and then I'd put names of people in that spot. So like if I did 3, 4, that would be who's sitting in row 3, column 4. So row 3, well, that'd be 3 back. So 1, 2, 3, column 4, 1, 2, 3, 4. So Ian would be sitting in row 3, column 4. Now, so 2D works perfect. But what if you wanted to make a seating chart for the entire school? Well, there might be somebody else in row 3, column 4 in a different room. So then what I'd do is I'd probably make a 3-dimensional array where this is still the row, this is still the column, but then this would represent the room. So I could assign a room number to each classroom. And I could say, okay, in room 2, who's sitting in row 3, column 4. So now it's 3D. Room, row, column. That would be the use for a 3D matrix. And then you could even make it a 4D matrix if you had, say, you wanted to make a seating plan for the entire district and you had multiple schools. So then you'd have to have, okay, what school, what room in the school, then what row, then what column. So you could make a 4D matrix, okay, depending on how much stuff you want to describe. Any questions on that? But we're going to stick with 2D. That's all we're going to do. And the main advantage of a matrix is it saves Well, first of all, it's a very organized way to solve a system, and we don't have to write letters. So all we're going to do is put the number that's in front of the letter. We do not care about the letters at all. And the letters are half of what you write when you're solving a system. Like if we're using X, Y, and Z, you end up writing the X, Y, and Z quite a bit. Well, we're not going to write them at all. So then, how do we keep track of the letters if we're not writing any letters? Well, we set up a system of equations. For example, let's say 3x plus 2y plus z equals 4. If I was going to translate that one equation into a two-dimensional matrix, it would have a 3, a 2, a 1, and then the 4 is on the other side of the equal sign. So what I'm going to do is I draw a vertical line that represents my equal sign and put the 4 on the other side. The first column is always going to be the x's. The second column is always going to be the numbers that were in front of y. And the third column is always going to be the numbers that were in front of z. That's how we're going to keep track of what number went with which letter. X's, y's, z's, other side of the equal sign. And when you write something like this, all you're doing is writing down coefficients. The 3, the 2, and the 1. Because this entire part is going to represent coefficients, it's called coefficient matrix. There would be 2 more rows in here. Because if you're going to solve a system of 3 variables, you need 3 equations. So you'd have 3 of them. I just did 1 to show you. But if all you do is write down your coefficients, all you've done is write down the numbers on this side. You need to add on to that, or what we call augment the coefficient matrix with a column that represents the numbers that come on the other side of the equal sign. And that's what this is. It's a column that we add on, but we separate it with a vertical line. We remember, okay, that's the other side of the equation. And that represents the number that was on the other side. Yeah, there's a lot you can do with matrices. Okay? The only thing that we're going to learn how to do is solve a system. And even the way I'm going to show you is only one way to use a matrix to solve a system. There's many ways. And besides just solving systems, there's tons of other things you can do in math with a matrix. In fact, there's so many different things you can do. They have an entire course that's just about using matrices in math. It's called linear algebra. And that's all you do in the whole class is just learn about things you can do with matrices in math. And you'd learn this. This is probably like something you'd learn on the very first day, what I'm going to show you here. Okay, so what's the goal? Well, the goal is to take, this is what your coefficient matrix is usually going to look like. You're going to have a bunch of numbers in it. You're going to have numbers on the other side. And these would represent the 3 equations that you have. 1x plus 3y plus 4z equals 3. That would be the first equation. Well, the goal is to take all of these numbers and make something happen to them. When we're done, we want to end up with something that looks like this. That could be anything. That could be anything. That could be anything. And that. So where I put squiggles, I don't care what ends up there. But where I put numbers that are zeros and ones, I definitely want that to happen. So my goal is to somehow turn all of these numbers into something that looks like this. Ones on the main diagonal and zeros below. What happens in these other spots? Don't really care. So let me explain what that is. So the goal is to get ones on the main diagonal and zeros below. I think the picture I just drew is better than this one. When you get ones on the main diagonal and zeros underneath it, that's called row echelon form. Which I'm going to abbreviate REF, row echelon form. Now, when I had this picture up here before, I said I don't care what happens above the main diagonal. If I did care about that, and I also tried to get zeros in all these spots, that's called reduced row echelon form. We don't get into that. That's where you get zeros below and above the diagonal. We're only going to focus on zeros below. Now, how are you going to get ones and zeros in those spots? Well, you can't just do anything you want. There's certain rules that you have to follow if you want to change these numbers into those numbers. And the rules, there's basically three rules that you are allowed, or three things that you're allowed to do. And those are called elementary row operations. They are the three things that you are allowed to do to a matrix to try to make it look the way you want. Well, one thing you can do is you can take any two rows and you can swap them. Swapping rows in a matrix will not mess up the final answer. Okay, you can't do anything that would mess up the final answer. Swapping rows will not. So that's okay. The other thing you're allowed to do is you can multiply a row by any number that's not zero. So if you had a row like this one, and you wanted to multiply everything in this row by 1/2, you could. So you could have 0.5, 0, 2.5, 2. That would be fine. Multiplying a row by any number that's not zero is perfectly okay. And the third thing you're allowed to do is add rows together. And we've done that when we do elimination. So usually when you get to a certain step in elimination, you might have something like this. And the goal eventually with elimination is to get two variables that have the same number but opposite sign. So then, when you add the two rows together, something cancels out. We're going to do a lot of that. We're going to try to make it so we add two rows together and we get a 0, so something would cancel out. Okay, and then you continue from there solving it. So you're allowed to add one row to another. Those are the only three things you can do. Any questions on what I mean by any of those three row operations? All right. So let's try an example. So we're not doing this problem again. This is the first time we're doing it. But I want to solve it using a matrix. So first step is to take everything you have here and translate it into a matrix. Get rid of the equal signs, get rid of all the letters. So if I want to write that as a matrix, what would my first row in the matrix B?
1, -2, 1, and then -1.
1, -2, 1, and then,
-1.
so there's your first row. How about my second row?
2, 3, -2.
All right. And my third row.
1, 3, -2.
Okay. So I told you kind of in general, the goal is to get ones on the main diagonal and zeros underneath it. But you have to do that in a certain order. Because once you get something the way you want it, you don't want to mess that up. So I'm going to show you the order to do it in so you don't mess anything up. And I'm just going to go through that order first. So the first thing you want to do, I'm going to erase these after because I don't want to have all these symbols in it, but I'll put them for now. The first thing you want to do is make sure that you have a 1 in the upper left. The second thing you want to do is get a 0 underneath it. And the third thing you want to do is get a 0 underneath that. You do those 3 things first. Once you get the first column set, you never touch the first column again. Now you move to the second column. And the fourth thing I'm going to want to do is get a 1 in that spot. And the fifth thing I want to do is get a 0 underneath it. So at this step, I would have a 1, 0, 0, 1, 0. And the sixth thing I want to do is get a 1 in that spot. And once you deal with those 6 numbers, you should have something that looks like this. You get that first, second, third, fourth, fifth, sixth. So you do column at a time. That's how you do it. And by following that pattern, you will not mess up anything once you get it the way you want. Okay. So first thing would be to get a 1 in the upper left. What do you think about that in this one? We already have it. In fact, I have 2 number 1s in the first column. If I didn't, because I already have a 1 somewhere, this would be a good example of swapping 2 rows. If I had a 1, let's say it was down in the second row, I would swap the second and the first row to make sure I get the 1 up in that one. The notation that I'm going to use to swap something is going to look like this. An arrow pointing each way means to take rows 1 and 2 and swap. All right, so that step is already done. So now we're at the second step. What number do I want to get in the second step?
0.
0. And the third step?
0.
0. So I want zeros in both of these steps. This is the only step I'm going to do 2 things at once. I'm going to deal with both things you just said. So I want to think about what I would have to add to this number to turn it into a 0. Right? So what would you have to add to 2 to make it a 0? You'd have to add -2. So we're going to add the top row to the middle row. But we're going to have to multiply the top row by something first. What would I multiply the top row by and then add it to the second row so it makes that a 0? -2. So I'm going to show you how we write that down. We're going to take the first row, we're going to multiply it by -2, and we're going to add it to the second row. And that, this arrow means we're basically going to put the answer in what's in the second row right now. If you just do this part, you actually haven't written anything down. It's like this is all in our head. The first row times -2 plus the second, where do you put it? I'm going to put it in the second row. Right, now we're going to do it again. We want to get a 0 in the spot that's labeled number 3. what would you have to add to 1 to make it 0?
Negative 1.
-1. So I want to think about what I would have to multiply the top row by. So when I add it to the third row, it makes that a 0.
Negative 1
Yeah.
times row. Column, get row 1
Row 1.
plus 3.
And we're going to add that result to row 3. And that's going to replace what's currently in
Row 3.
row 3. So that's the calculation we need to do. Let's try. Okay, so -2 times the first row. You've got to do it 4 times. We've got to do each element. So row 1 isn't changing at all. Let's copy that down. In fact, row 1 is not changing this entire problem. Row 1 is done. All right, so -2 times the first row. What's 1 times -2? Plus 2.
0.
0. Do it again. What's -2 times -2?
4.
Plus 3.
7.
1 times -2? Plus -2.
Negative 4.
And -1 times -2?
2.
2 minus 3.
Negative
Okay, so there's your second row.
So we add, we're adding down. Okay.
Now let's do the third row. -1 times the first row added to the third row. Okay, what's 1 times -1? -1 plus 1. 0. Let's do it again. What's -2 times -1? 2 plus 3. 5. 1 times -1 plus -2. And -1 times -1
1.
plus -2. -1. Okay, so now I have 3 values the way I want them. I got a 1 in the upper left, I got a 0 here, and a 0 here. So essentially what I've done is I've reduced my problem from 3 variables with 3 equations down to 2 variables and 2 equations. Because if you were to write this back out, it would say 7y minus 4z equals -1, and 5y minus 3z also equals -1. So now we're going to do that one more time. We're going to eliminate one more letter, and then we're going to have 2 zeros in the same row. And then we'll know one of our answers. Okay, so now the next thing we have to deal with is the item in position 4. What do we want position 4 to be? We want it to be a 1. So there's only one way that we can make this a 1, and that would be by multiplying this row by what? 1/7. I don't like to get into fractions. Sometimes you have to. The other thing you could do is you could swap rows 2 and 3, and then you'd have a 5 in that spot, but then you'd still have to multiply by 1/5. So you're either going to deal with 1/5 or 1/7. Let's leave it the way it is and just multiply it by 1/7. Right? And if we need a calculator for fractions, we'll do that. Okay, so let's, I'm just going to write it right underneath. Let's take the second row, multiply it by 1/7, and that's going to replace what's currently in the second row. So what rows aren't changing this time? 1 and 3. Let's copy them. 1, -2, 1, -1, 0, 5, -3, -1. And we're only going to get 2 numbers that are fractions. That's not bad. Multiply everything by 1/7 in row 2. What's 0 times 1/7? 7 times 1/7? And then -4/7. And my last one? -1/7. Okay. So now we just dealt with the fourth item. Now we got to do the fifth item. What do we want to get in position 5? I want to get a 0. You're done using row 1. If you use row 1 to do anything else in this problem, you are going to mess up these zeros. So now we're going to use row 2 at this step. What could you multiply row 2 by so that when you add it to row 3, this becomes a 0? Negative 5. Yep. So we're going to do negative 5 times the second row. We're going to add that to the third row, and that's going to replace what's currently in the third row.
There's a lot of replacing in this.
Yeah, replacing every step, really. I'll draw a line so you can see each step. Which rows are not changing? 1 and 2. 1 and 2 are done for this whole problem. We're done. So copy them over. 1, negative 2, 1, negative 1, 0, 1, negative 4/7, negative 1/7. Okay, so now multiply everything by negative 5 and add it to row 3. What's 0 times negative 5?
0.
Plus 0.
0.
0. That's why we use this row, because I know it wouldn't mess up the one underneath it. What's 1 times negative 5? Plus 5.
0.
0. Okay. What's negative 4/7 times negative 5?
Negative 27.
Positive 27. Just going to use a calculator. That's going to be easier. Positive 27. 27. Plus, what's in this row? Negative 3.
Negative 1/7.
Is that what it comes out to?
Yeah.
Yep. Negative 1/7. Yep. And now let's do it one more time. Negative 5 times our value, added to the third row. What's negative 5 times negative 1/7?
5/7.
So that's 5/7. And we're going to add that to what number?
Negative 1.
Negative 1. Again, if you want to do it in your head, you can. I just want to make sure I don't make a mistake. So negative 2/7. Okay, so now I have what I want in the fifth spot. I don't really have to deal with the sixth spot if I don't want to. At this point, I can look at what I have and translate that last row back to an equation. What does this tell me if you wrote it with x, y's, and z's?
C is negative 1/7 z equals negative 2/7.
Right. It says 0x plus 0y minus 1/7 z equals negative 2/7. This is an equation now with only one variable in it that I can solve and get z. What would you multiply each side by to get z by itself? Negative 7. So you'd have negative 2/7 times negative 7. Well, negative times negative is positive. And what do you get for z? 2. So now we know z is 2. Now let's go back up to the middle row. What does that middle row tell me if I wrote it back out as an equation?
y1 minus 4
Well, just say y. So you get y
minus 4/7 c
minus 4/7 z
equals negative 7.
equals negative 1/7. Okay. So there's what the second row tells me. Now, what do I already know?
C.
I already know z. What's z? 2. So fill in 2 for z. So y minus 8/7 equals negative 1/7. And we're going to add 7s to both sides. And what are we going to get for y? 1. Yep. So there's how you get y. So we've got z, we've got y. The only thing left is x. Well, to get x, we can go back up to any one of the original equations. Let's just use the first one. X minus 2y plus z equals negative 1. Okay, let's see, y is 1, so we're going to get negative 2 times 1 is negative 2. And what was z? 2. Well, minus 2 plus 2, that's gone. So x equals negative 1. And that's how you get x, y, and z. When you solve using a system, generally, or solve using a matrix, if nothing special happens, that's generally the order you find them in. Z, then y, then x. Okay, so any questions on the... That was basically the matrix part of this problem right there.
Just go on.
Any questions?
Sorry, you should wait for X again.
Yep, we just substituted. So the reason we have to do all this substitution at the end is because we're only really doing half of what's called reduced row echelon form. We're getting 1s on the diagonal, and we're getting 0s under it. If we got 0s above, then we wouldn't have to go back and do substitution. So you either do it the way we're doing it, and then use substitution, or fully finish it and get 0s above and below, and then you end up with something that looks like this. And then the 3 numbers that you get on that side are your answers without any substitution, because this one says 1x equals that, 1y equals that, 1z equals that. But we're going to stick to the way that I showed. Any question on that? All right, let's try another one. Now, sometimes when you have a variable missing, that's helpful because it means you already have a 0 in one spot. Sometimes that's not helpful at all. Depends. If it's in a spot that we already need a 0 in right away, then it's helpful. If it's in a spot that we're not dealing with right away, then it doesn't do much for us. Okay. So there's something I would do is I write this problem down right away. It's actually 2 things I would do. What's the first number that we want to deal with is in the upper left. And what number do we always want that to be? We want it to be a 1. So what might you want to do as kind of like an unofficial step before you even start the problem? Just take care of this right away.
Did you swap rows 1 and 3?
I would swap rows 1 and 3, and I wouldn't even count that as part of the problem. I would just write the problem down that way. So then you would have 1, 6, 8, 4, and I'm going to pretend that's how it was originally given to me. And then row 2, I'm going to leave right where it is.
Wait, sorry, why did you put the bottom one first?
Why did I put the bottom one first?
To switch rows, you can get a 0. 3 numbers.
Well, actually, I guess we didn't have to swap rows 1 and 3 because we already had a 1 in the upper left anyway.
But by putting row 1 in the bottom, you get a 0 and a 1 in the spot.
Yeah, I
you're gonna
see.
need
Okay,
anyway.
that makes sense.
Yeah, I mean, we get a 0 here, but we're going to have to mess that up anyway. It doesn't save us anything because we can't deal with the second column till we finish with the first column. So swapping them here actually didn't help. I didn't notice that.
Not even that.
Doesn't hurt anything.
Not
It's
even-
okay. It's okay.
What?
Not even one that bottom right. Just
If you have things the way you want to eventually get them, but they're over in these columns and you haven't dealt with this column yet, then you're probably going to mess these numbers up. You have to. You have to get the numbers left to right. So let's just make sure we swap the rows. Unnecessary, but let's make sure we have the right numbers. 1, 0, 1, 4. One thing that I definitely would have done is I would have multiplied row 2 by a half. That I would have done because then it would have made the numbers
Small.
Oh yeah, there's a 1 and 2.
I mean, we could just erase row 2 and put everything in as a half. As kind of a step that we did before we even started. So 1, 1, 2, 5. If we want. It's not necessary, but it does make the math a little bit easier. Okay, so we've got a 1 in the upper left. Next, we want to get a 0 underneath it. So what would you have to multiply row 1 by to get a 0 in this spot?
Negative. Oh wait. So to get a 0.
Negative 1 times what row?
1,
Added to what row?
2,
And that's going to replace what's currently in
2.
row 2. All right. Now we want to get a 0 in that spot. So what are we going to multiply row 1 by to do that? Same thing. Negative 1 times the first row. Added to the... No, we're done with the second.
Would be
Added to the third. And that's going to replace the third row. So what row doesn't change? The first. Okay, so now multiply everything in row 1 by negative 1 and add it to row 2. What's 1 times negative 1?
Thanks.
Plus 1.
0.
6 times negative 1?
Negative 6.
Plus 1.
Negative
8 times negative 1?
Negative 8.
Plus 2. And 4 times negative 1? Plus 5. Okay. And now do it again, but we're going to do something with the third row. Negative 1 times the first added to the third. Okay. So what's 1 times negative 1?
Negative 1.
Plus 1.
0.
Okay. 6 times negative 1?
Negative 6.
Plus 0.
Negative 6.
And 8 times negative 1?
Negative 8.
Plus 1.
Negative 7.
And 4 times negative 1?
Negative 4.
Plus 4.
0.
In fact, we got a 0 there. Means nothing, but that's what happened. Okay, so the first column is done.
Nice.
Now, what's one way that you could get a 1 in that spot?
5 1 negative 5.
Multiply by what?
Multiplied by negative 1
You could multiply everything by negative 1/5. Yep, you could. And it would probably work fine. Or, does anyone see how you could get a 1 without multiplying by negative 1/5 by kind of doing something with these two rows? Yeah?
Multiply the bottom row by negative 1 and then add to the second.
Yeah, if you multiply the bottom row by negative 1 and add it to the second, you won't mess up any of your zeros that are already here, but you'll make that a 1 without multiplying through by negative 1/5. So sometimes we see tricks like that,
Yeah.
and we do that instead so we can avoid the fraction. So let's try it. So let's take negative 1 times the third row, add it to the second row, and that's going to replace what's in the second row. So rows 1 and 3 don't change this time. So 1, 6, 8, 4. 0, -6, -7, 0. And now let's multiply everything by -1 and add it to what's above it. What's 0 times -1?
0.
Plus 0?
0.
Okay, you would not want to do that if it would have messed this 0 up. But it doesn't because there's a 0 under it. So it can't mess it up. Okay, now the next one. What's -6 times -1?
1.
6
5.
plus -5? 1.
5.
What's -7 times -1?
7.
7 plus -6? 1. And what's 0 times -1?
0.
Plus 1? 1. So that was a lot nicer way to get a 1 in that spot by multiplying by -1/5.
So was the only thing that we really needed from that changing the bit was their fourth position total? That was all we did that for.
Yes, I just wanted to get a 1 in this
Yeah.
row 2, column 2 spot.
Alright.
Yep. Okay, what's the next spot that I focus on? What row, what column?
Row 2, column 3.
Row
Row
3, column 2. And what do we want to happen to that number? We want it to be a 0, and we can do that very easily when there's a 1 above it.
Oh, so we just add it to the bottom.
So how are we going to get a 0 in that spot?
-6 times row 2.
Mm,
Sorry, no, 6 times row 2. not
Yeah.
6.
If you take +6 times row 2, and you add that to row 3 and replace what's in row 3, you will get a 0 in the spot that I put the box around. Okay, so what's not changing this time?
Row 1.
Row 1 and
Row 2.
row 2. So 1, 6, 8, 4, 0, 1, 1, 1. And now multiply everything by 6 and add it to what's below. What's 0 times 6?
0.
Plus 0?
0.
Okay, we should never mess up those zeros from this point on. 1 times 6 plus -6.
0.
1 times 6,
6.
6 plus -7.
-1.
And 1 times 6
6.
plus 0.
Sorry, what you said. Yeah, 6.
6.
So that.
So now what does that last row, if you change it back to an equation, tell me? Negative z equals 6. So z equals -6. Let's go back up a row. What's that second row tell me? Y plus z equals 1, and z is? So y minus 6 equals 1. So now we got y. And now go back up to the top row. What does the top row tell me as an equation? So x plus 6y plus 8z equals 4. X we don't know. What's 6 times y? 42. 8 times z?
-48.
So that's going to be 8 times -6, which is really a -48.
Right, sorry.
And what's 42 minus 48? -6. So x equals 10.
Wouldn't it have been just been easier to go back to our original problems and do x plus z equals equals.
Yeah, I was thinking that.
Yeah, was there an easier one?
Yeah, it's just x plus z.
It has y gone.
Yeah, so if we use this one because y is already gone, x plus z equals 4. That one, yes, it would have been easier. So it would have been x, what was z?
Negative 6.
So you would have had x. So you end up at the step that we were at in the second step of our problem, but you end up there in the first step. Yep. So whichever equations you find are the easiest, I agree that x plus z equals 4 would have been easier.
So is our final answer trying to get x, y, and z? That's what we're trying to do.
3 answers, yeah. X, y, and z. And notice we got them exactly in the same order we did last time. Z was first, y was second, x was third. That's generally how you do it. Okay. Any question on that? So this is the kind of thing that, like, when you're doing one of these problems, you really don't want anyone to bug you because you kind of get in the middle of it. And if you lose track of like where you're at and what row and column you're working on, then sometimes you have to start over. So you really have to concentrate.
The mindset for it.
Yeah, you really kind of gotta concentrate on it. All right, I guess we could try one more. There's some zeros all over the place in this one. And not every 3x3 system comes out to integer answers, but the ones that I do generally will. Because if they don't come out to integers, then the math starts to get really kind of messy. Okay, now, definitely something I would do this time based on the first thing you want to achieve.
Swap rows 1 and 2.
Definitely swap rows 1 and 2. You've got to get a 1 in the upper left. This is the only thing that's a 1. Now, let's say this wasn't a 1. Okay, don't write this down. But let's say this was a 2. Well, now, to get a 1 in the upper left, you're probably going to want to multiply one of these rows by 1/2. That's the only way you're going to make one of them a 1. But we didn't have to worry about that because we already had a 1. So let's swap rows 1 and 2 as the first step. So we get 1, 3, negative 1, negative 3, and then 1, wait a minute, no, 2. Minus 1. What's the z value?
0.
Yeah, there is no z value. And 0 doesn't really help me, other than maybe it makes arithmetic a little easier. So make sure we get it right. 1, 3, negative 1, negative 3. 2, negative 1, 0. Yep. And what's going to be my x value?
0.
That does help me, because I needed to get a 0 in that spot. It's one of the first things I have to do in that column, and it's already there. So that's a good thing. Okay, so now the only thing we have to do is fix that. What would you multiply row 1 by? Yep. So negative 2 times the first row. Add it to the second. And where's that going to go? Second row. Normally we have to do 2 things at this step. There's only 1. So which 2 rows stay the same?
1 and 3.
So 1, 3, negative 1, negative 3. 0, 3, 1, 8. Okay, multiply everything by negative 2 and then add it to row 2. 1 times negative 2 plus 2. 3 times negative 2 plus negative 1. All right, 1 times negative 2 plus 0. And negative 3 times negative 2 plus 0. Okay. Now, what is one way that you could get a 1 in this spot? We got to think of it as multiplying. Multiply by negative 1/7. Yes, you could do that. But there's another way that we can get a number at least pretty close to a 1 in that that spot. We can't exactly get a 1, but we can get something close to it. And then we could fix it. Does anybody see what we could do?
Could we multiply row 3 by 2 and then add it to row 2, and then you'd have to multiply row 2 by 1 to fix it?
So, yeah, we could take 2 times the third row and add it to the second and replace what's in the second. That's not going to give you a 1, but it's going to give you a -1, which is close enough.
And then you just do one more step to turn it positive.
And then you could just change the sign of everything in that row. Now you could try to do that all in your head in one step, but let's do it in 2. So we got 1, 3, -1, -3. We've got 0, 3, 1, 8. Now what's 0 times 2?
0.
Plus 0. Okay. What's 3 times 2?
6.
Plus -7.
-1.
1 times 2?
2.
Plus 2.
4.
And 8 times 2?
16.
16 plus 6.
22.
Okay. So the downside of doing something like this is you will start to get bigger numbers. But the upside is we didn't have to divide, we didn't have to get fractions. I'm not saying you can always avoid fractions. If the answer is a fraction, you're gonna get fractions at some point. But for now, we avoided it. And what could we do now in the second row?
Make everything kind of the opposite. So multiply -1 to row 0.
Yep. Multiply -1 to the second row. Don't add it to anything. Just do that and replace what's in row 2. So 1, 3, -1, -3. 0, 1, -4, -22. And 0, 3, 1, 8. Okay. So now, what row and column do we want to focus on next?
Row 3, column 2.
Row 3, column 2, and we want to make that a
0.
0. So, what would you multiply row 2 by to make that happen?
-3.
Yep, -3 times
Row 2.
row 2 added to row 3 and replace row 3. So what stays the same?
1 and 2.
1, 3, -1, -3. 0, 1, -4, -22. And well, we know that's a 0. What's 1 times -3? Plus 3.
0.
4 times -3?
12. 12. Yeah. 4 times -3 is -4 times -3.
Yeah, -4 times -3. 12 plus 1.
13.
And -22 times -3.
66.
66 plus 8.
74. 66 plus 8.
66 plus 8.
74.
70 what? 4. There are a couple different answers. 74. All right. What's my last row? Tell me.
That Z equals 13. Yeah, 13Z equals 74.
13z equals 74. So z, 74 divided by 13, we're just going to have to leave it as 74/13. So this is one that it's a fraction. Okay, what does my second row tell me?
That Y, yeah.
Y minus 4z equals -22. So y,
Would it be easier to use one of our starting equations instead? Is the bottom one any easier?
well, we're trying to solve for y. So
We don't have.
The bottom one, I mean, sorry.
3y
Is the third one any easier than what we're doing?
plus z equals 8.
It's very similar.
Yeah, I don't really know. We got these fractions, and we're just going to use a calculator anyway, so probably about the same. Okay, so we end up with y minus 4 times 74/13. Okay, let's do that out. So what's 74 times 4? 296 thirteenths. And how would I move that to the other side? Yeah, so I'm just going to use the calculator to figure that out. So negative 22 plus 296 over 13?
Yeah.
Okay, so I'm going to get that, and then I'm going to convert it to a fraction.
Oh, you didn't.
10
I didn't.
thirteenths.
That's very handy.
What do you press? Have you converted it to
Oh, yeah. When you press to do that?
Math, and then the first option.
If your most recent one was a decimal.
Yeah.
Just math.
If it's a decimal that can be a fraction, it'll do it.
Yeah.
If it can't, it'll give you back the same decimal. All right, and then x, I would definitely say the top one, 2x minus y equals 0. That's probably the easiest. Okay, so 2x minus y equals 0. Actually, yeah, it's not going to be bad at all. So y is negative 10 thirteenths. So what does 2x equal?
Positive 5/13.
And then dividing each side by 2.
Yeah.
What's half of 10 thirteenths? 5 thirteenths. So even though we got fractions, we were able to avoid fractions right up until the very end. And it wasn't too bad, especially with the calculator, to convert for you. Hopefully we did everything right. I mean, it seems reasonable. But I don't have the answer to that one. So. Okay, any questions on that? Now, there are some special things that can happen, like when you start to solve a matrix, instead of ending up with like a 0 in one spot, all of a sudden you end up with an entire row of zeros. Like everything cancels out. We're not going to look at ones where that happens. But when everything cancels out like that, you either end up with no solution or infinite solutions. So this would be an example of infinitely many solutions. That would be an example of no solution. Because there's no way you can multiply 0 times something plus 0 times something, and get 10. You'd get 0. So that would be a no solution. If you got all zeros, and then a number on the other side that wasn't 0. Okay. But we're not gonna examine those cases in this section. Okay. So in the homework, you're going to end up with some systems like this. I don't know why people seem to get almost more confused doing it on a 2x2 system than a 3x3.
Just be a 1 row 1.
Yeah,
row 2.
the goal is to get a what in this spot?
A 1.
A 1. And then this spot? 0. And then this spot?
A
A
1.
1. And then you're done.
It's as if though you already completed the first row.
It's like you've already done the first one, yeah. So it's actually easier, but sometimes people get tripped up with it.
Dang.
Okay, so there's 12, I think 12 questions for homework. 1 through 6. 17, 18, 21. 24, 31, and 32. If those were all matrix problems, that would take a while. But I think they're not. So yeah, 1 through 6 is just describing. There's no matrices involved at all. 17 and 18 are 2x2s. And then 24. And we're going to skip 32. Okay, so 11 questions. The only 3 variable problems are 21 and 23. Everything else is a 2 variable problem. 31 is a word problem, but it's a 2 variable problem. I think it's something about like tickets being sold to a zoo. There's like adult tickets and child tickets, something.